Hi friends, welcome to Triple Students YouTube channel. So in this class we are going to know about the um, Mason gains formula. Okay, reduction of signal flow graph. Reduction of signal flow graph using Mason's gain formula. Okay. So reduction of signal flow graph using Mason's gain formula. So okay, coming to the topic, Mason's gain formula. Okay, Mason's gain formula. So Mason gain formula is used to determine the transfer function of the system from the signal flow graph of the system. So this method is used to find the transfer function or overall gain from the signal flow graph Okay, now let R of S is the input of the system, C of S is the output of the system. Okay, R of S is the input of the system and C of S is the output of the system. And coming to now, transfer function of the system is transfer function of the system is T of S, that is equals to C of S by R of S. Let it be equation 1. Okay, so T of S is the transfer function of the system. Now we are going to know about the Mason's gain formula. Okay, now we are going to see the Mason's gain formula. System. Oh, T of S. So Mason's gain formula states the overall gain of the system or transfer function. We call it as transfer function in the block diagrams like that. Okay, as follows. Okay, now overall gain T is equals to 1 by delta summation of K into Pk del K. Very important formula. Maybe it is going to ask in 2 marks also. Very important thing. Okay, now we are going to see what are the things. Where T is equals to T of S is equals to transfer function of the system. Good morning, Sunil. Overall function of the system. Okay, now transfer function of system Pk is equals to forward path gain of kth forward path. So we all discussed these things in our previous video, like forward path gain, forward path loop, closed path, open loop path, like that. Okay, we all know everything. In the if you can't understand these terms, you just go and see in the previous classes. Okay, good morning, Pawan. Okay, K is equals to number of forward paths in the signal flow graph. Okay, now we are going to know about delta is equals to 1 minus sum of individual loop gains, individual loop gains. Okay, good morning Jagada Murali. Okay, plus sum of gain products of sum of gain products of all possible combinations of two non-touching loops, two non-touching loops, two non-touching loops. Good morning Magita. Minus sum of gain products of all possible combinations of three non-touching loops. So plus and so on. Okay, so this is the overall formula for the so now we are going to find all these terms and substitute in the overall gain in this formula. Okay, okay, so students, okay, good morning. So now we are going to draw a signal flow graph and see what are the things happen, how we are going to find out the transfer function of the system. Okay, transfer function of the system and forward path gain of kth forward path, number of forward paths in the signal flow graph, and delta here remain is a delta. Okay, delta is nothing but sum of individual loop gains plus sum of gain products of all possible combinations of two non-touching loops, sum of the gain products of all possible combinations of three non-touching loops. Okay, students, one more thing is we are here to know all the parameters we just discussed here in the previous class. Okay, so don't forget to follow the previous class. Okay, so this is a continuation part of that class. Okay, now we're going to see the formula. Find the overall transfer function. First problem is find the overall transfer function of the system whose signal flow graph is shown below. Okay, and the graph is let us take 8 nodes, 1 2 3 4 5 6 7 8. Okay, one, 2, 3, 4, 5, 6, 7, 8. Okay, 2 to 5. Three to and 3 to 5. G1 3 to 4 G2 and 4 to 5 G3, 4 to 5 G3, 5 to 6 G4, 6 to 7 G5. So the branches which nothing have a gain, let us assume it as 1. Okay, so this is the signal flow graph. Now we are going to reduce the signal flow graph. Okay, let us see the formula. We are from the signal flow graph, we are going to find out all these things. Okay, all these things what we are going to discuss in the problems. Okay, these two things. Okay, now let us see what happening here. First thing is we are going to find out so first step we are going to find the forward paths. Forward path gains. How many forward path gains? So see here, how many forward path gains are there? See here, the forward path gains. Once you have go to back to the previous class, how to find out the forward path gains? How to find out the forward path gain? We already discussed in the earlier terms. Go to the terms discussed in the okay. See here. So from here forward path gain. So see, it is the product of branch. It's a gain. Now we are going to find out first what is forward path. How many forward paths are there? So forward path is, it is a path from an input node to an output node. So it is a path from input node to output node. See, so forward path is nothing but it is a path from an input node to an output node that does not cross any node more than once. So forward path is nothing but it can travels from input node to output node. Here input node is, see what is input node? The node which has only one outgoing branch. See here it has only one outgoing branch. That's why it is known as a input node. Only one incoming branch is output node. So 8 is a output node, 1 is a input node. So okay, see here forward path is nothing but it is a path from an input node to an output node, from here to here, that does not cross any node more than once. So the signal is forward path, the path which has moved from 1 to 8 doesn't cross any node more than once. It doesn't cross the node more than once. Okay, see here 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8. So first forward path is like this. First one 1, 2, 3, 4, 5, 6, 7, 8. Okay. G1, G2, G3, G4, G5. Okay, so this is the one forward path. See, is there any one more forward path? So the path which travels from an input node to output node which doesn't cross the node more than once. See here 1, 2, 3, but here the signal comes in towards the point, and here also this see branch again close to here. So see 1, 2, 5, 6, 7, 8 is one more forward path. See, the signal moves from 1 to 2, 2 to 5, 5 to 6, 6 to 7, 7 to 8. It doesn't cross any node more than once. So 1 2 5 6 7 8. Okay, 1 to 2 and 2 to 5. See here, 5 to 6, 6 to 7, 7 to 8. Okay, so this is the another forward path, and the gains here are 5 to 6 is G4, 7 to 8 is nothing but 1, 6 to 7 is G4, and 2 to 5 is G6. So see here, so we have totally 2 forward paths. So as we discussed that K is equals number of forward paths in the signal flow graph. So how many forward paths are there? K is equals to 2. Why? Because 2 forward paths. That's why we have 2 forward paths in the signal. Okay, next, let this forward path be P1 and P2. This forward path be P2. Okay, so we have totally 2 forward paths. So our first step is completed. No, sorry, not completed. So forward path gain of forward path 1 P is equals to P1 is equals, see how many gains are there? G1, G2, G3, G4, G5. So this is the forward path gain. So this one is the forward path gain is P1 is equals to G1, G2, G3, G4, and another one is P2 is equals to gain of forward path 2 is P2 is equals to G6, G4, 5 to 6 is G4, okay, G4, G5, G6. Okay, so we have 2 forward path gains. So we have 2 forward path gains, those are P1, P2. Okay, guys, it is audible to you? Please reply, give a reply. The topic is understanding for you. Don't worry if it is not understand, you just go to the previous video. Okay, and the second is we are going to find the individual loop gain. Okay, we are going to find the individual loop gain. And the another step is we are going to find the individual loop gain. Individual loop gain. Individual loop gain. So see, from the problem we are going to find out how many individual loops are there. Okay, Dimple, thank you. So now we are going to find the individual. There are how many? First of all, we are going to know what is a loop. A loop is nothing but a signal which ends at the point where it is started. Is it a loop? See here, how many loops are there? So 3, 4. Let us notice the 3 and 4. See here, the signal starts from 3 and ends at the same signal 3. So 3, 4 and again 3. So it is a loop. Okay, so 3, 4 is a loop. 3, 4. It starts from 3 to 4. So it is a loop. So what are the things present here in the 3 to 4? G2 minus H1. And next see, 3 to 4, 4 to 5, 3, 4, 5, 3, 4, 5. So 3, 4, 5 is also a loop. sorry, here I missed one loop in the question. 6 to 7 also has a loop. So 3 4 5, 3 4 5. Okay, so see how it happens. 3 to 4, 4 to 5. So the arrow shows 3 to 4, 4 to 5 and 5 to 3. So the signal starts from 3 and it ends at the 3. So then it becomes a loop, individual loops. Okay, now G2, G3 minus H2. Okay, minus H2. And finally one more another loop is 6 to 7. So 6 to 7, 6 7. So these two also a loop. So 6 to 7 is G5. H3. So these are the three individual loops we got from the signal flow graph. Okay, now we are going to find the loop gains. Okay, so for this one we noted as P11, P11, P12, P13. So the gain of this one is minus G2H1 and the gain of this loop gain is G2, G3 minus H2, and for this one minus G5 H3 minus G2, G3 H2. Now what are we going to gain product of the two non-touching loops? Next step is we are going to find the gain product of two non-touching loops, and next step is gain product of two non-touching loops. So what is meant by non-touching loop? See here, non-touching loops. Input node, output node. See here, non-touching loops. See, if the loop doesn't have a common node, then they are said to be non-touching loops. Okay, the loop which doesn't have a common node, then they are said to be non-touching loops. Okay. See here, we have three individual loops. Is there any non-touching loop here? So compared to these two loops, 3 4, and there is also a non-touching loop 3 4. Coming to 3 4 6 7. So 3 4 and 6 7 are a combination of two non-touching loops. So 3 4. So 6 7 and 3 4 is a combination of non-touching loops. So then what happens? P12 is equals to product of two non-touching loops. We are going to make a product. So what is the product here? Minus G2H1 into minus G5H3. What happens here? G2, G5, H1, H3 is the gain product of two non-touching loops. See, is there another one combination also for the non-touching loop? See here 3, 4, 5, 6, 7. These two loops don't have any common nodes. So these two are also a common. This is the first combination, and this one is the second combination. So right here what happens? What are the loops? 3, 4, 5. 3, 4, 5. G2, G3 minus H2, and another loop is 6, 7 minus H3, G5 combination. This is another combination. Now we are going to find out this. What we are going to take this notation as P22. Okay. Now see what happens here. Minus G2, G3, H2 into minus H3, G5. Now what happens? G2, G3, G5, H2, H3 is the gain of the two non-touching loops. H3. Okay, these are the things what we have find at the gain products of two non-touching loops, and is the individual loop gain, and these are the products of gain product of two non-touching loops. And our next step is to find the now we are going to find the calculation of del and delta k. So now we are going to find the calculation of del and delta k. Find the calculation of delta and delta k. Okay, now we are going to see delta is equals to 1 minus, what is the formula? You see here, the formula is 1 minus sum of individual loop gains. Okay, what is our sum of individual loop gains? See here, so these are the sum of individual loop gains. So P11 plus P12 plus P13, okay, plus what is next? Sum of gain products of all possible combinations of two non-touching loops. See how many possible combinations are there? Two combinations, that is P12 and P22. So next, so we are going to sum P12 plus P22. So and another sum of three non-touching loops. So we have only the three loops, but two are touching loops, one is not. That's why we got two combination of non-touching loops. So we can take from here. That's it. Now we are going to substitute the things here. So what is 1 minus P11 equal to minus G2H1, P12 minus G2G3H2 minus G5H3 plus, what are the two non-touching loops sum? P12 is equals to see here, 2 is equals to G2 G5 H1 H3 plus G2 G3 G5 H2 H3. Okay, now multiply this minus, what happens? 1 minus into minus plus G2 H1 plus G2 G3 H2 plus G5 H3 plus G2 G5 H1 H3 plus G2 G3 G5 H2 H3 is the value of delta. So this is the delta. Now we are going to find the delta k. So delta k is the, what is the for term we are used here? Delta k, just a minute. Delta k is the delta for the part of the graph, delta for the part of the graph which is not touching the kth forward path. Okay, so see here, where is the forward path? So we have k is equals to 2. Okay, so we have k is equals to, so we have two deltas. Okay, so delta k is equals to delta 1 comma delta 2. Why? Because we have two forward paths. See here, in the first forward path all the nodes are touched, so all the nodes are touched. That's why delta 1 is equals to 1. We can assume that, if not assume, let if the nodes all are touched by the signals, so here 1 to 8 all nodes are in the first forward path. That's why we can take that delta 1 is equals to 1. And coming to second forward path, see here, so 1 2, so 3 4 are the nodes missed. So 3 4 are the nodes not touching the forward path. So now we are going to find the delta for the 3 4 nodes. So 3 4. So coming to the loop 3 4. So 3 4 we have, this is the loop at the 3 4. G2 minus H1. So we are going to find the forward path. So see how many individual loop gains are there. Delta 2 is equals to 1 minus only one loop minus G2 H1. Is there any non-touching loops? No, everything has a touching loop, only one. So it is equals to 1 plus G2 H1 is the delta 2. Okay, now we are going to directly attempt the so now we are going to directly apply the formula here. Mason's gain formula. What is the Mason's gain formula? T is equals to, so to find the overall gain, so now we are going to find the overall gain. Overall gain is equals to T is equals to 1 by delta overall gain. T is equals to 1 by delta summation of k into pk del k. Now substitute all these things here. So T is equals to, what is the transfer function? So 1 by delta summation of, substitute k is equals to 2, so that we have P1 delta 1 plus P2 delta 2. Am I right? So P1 delta 1 plus P2 delta 2. Why? Because number of forward paths is 2. That's why we are going to apply k is equals to 2. Now delta, what is the value of delta? That is equals to, delta is 1 plus, substitute this delta here, 1 plus G2 H1 plus G2 G3 H2 plus G5H3 plus G2G5H1H3 plus G2 G3 G5H2H3. And P1 what is the P1? We already find the P1 value, forward paths. P1 is the forward path gains. Just a minute. See here, so that is equals to P1 delta 1. So P1 is equals to G1 G2 G3 G4 G5 is the forward path, and delta 1 is 1. So why? Because all the nodes are touching the delta 1. So that's why we can write like this, and plus P2 is equals to, so 1 plus G2 H1 into, so delta 2 value into P2 value is G4 G5 G6. So this is the overall transfer function. After solving this, what we get? Okay, see here, G1 G2 G3 G4 G5 plus G4 multiply these two things, G4 G5 G6 plus G4 G2 H1 G4 G2 H1 G5 G6 by 1 plus G2 H1 plus G2 G3 H2 plus G5 H3 plus G2 G5 H1 H3 plus G2 G3 G5 H2 H3. So see here, what are the common terms present in all these things? G4 G5 G4 G5 G4 G5. Okay, can we take the G4 G5 common in all the terms? G4 G5, or leave it as it is. So this is the overall transfer function of the given signal flow graph. So we can find all the terms given in the formula. Okay. Okay guys, comparing to all the things, we can easily by using this SJ Mason gain formula, we can write the formulas. So we can write the formulas. So this is the overall transfer function, G1 G2 G3 G4 G5 plus G4 G5 G6 plus G2 G4 G5 G6 H1. So by 1 plus G2 H1 plus G2 G3 H2 plus G5 H3 plus G2 G5 H1 H3 plus G2 G3 G5 H2 H3. This is the overall transfer function of the system. Okay, so like this we are going to find out the transfer function of the given signal flow graph. So I am going to give you a problem in this session, so you definitely So you can definitely do that problem in the afternoon session. Okay, just wait a minute, I will give. Find the overall transfer function of the signal flow graph given below. Okay. G2, G3, G1, G6, G1, G6, G4 minus H1, G6, G3, G5, G5 minus H2. Okay, every branch I give a gain. Okay, students. Okay, guys, this is the question. Is it everyone understanding the class today? Students, I am asking you. Friends, please reply me. Is everyone understanding this session today? So this is the problem. You have to give answer to me in the afternoon session. Okay, so don't forget, you are all giving the answer to this question in the afternoon session. Okay, so R of S, C of S, you are going to find out the T of S is equals to C of S by R of S. Dimple, you don't escape, don't give silly answers, but little difficult while solving the problem, sir. What problem I am explaining to you? The problem that I am explaining to you. Okay, you just see one more time this video. It is clearly understandable. I definitely give you the PDF to all your friends, the PDF material. After completing the first unit. Okay, don't worry about that. I give a perfect material for you. Okay, which is written by me. Okay, don't worry, students. If you have facing any difficulties, you just give a message to me in our groups or personally. I will solve at where you are struggling. Okay, in this subject, don't worry about that. Okay, so afternoon we also have one more session. In that session we are going to discuss about some more transfer functions of the DC motors, field controlled, armature controlled. Okay, don't miss the session. It's very very interesting. So if you want one more problem from the signal flow graph, Okay, you just comment me. I will definitely conduct a session for the problem. Okay, okay guys, thanks for watching. Thank you.